Thank you so much for joining, everyone. It's really great to see people here. I mean, just I don't know everyone that's joined, but you can really tell from the people that I do know that there are people here from all kind of different time zones and locations, and it means a lot to us. And it's the first real kind of community call that we're having. So we're going to be we're gonna have some trial and error with the format. We were debating a lot between having like a regular Zoom call and having this webinar type format. I think there are definitely advantages and disadvantages to both different approaches, but I'd love to hear feedback, or we'd love to hear feedback about this and what we should do for next time. I think like pros, for the Zoom side are, that it's much more easy to actually speak and be heard, but we're also going to upload this as a recording, so we didn't want to to have you concerned about like what you can and can't say in terms of privacy and who's going to watch it and so forth. Anyway, so just a bit of context who you have here on the call. We have here myself, the CEO of Deepchecks and co-founder, my co-founder is Shir. We have Nir Rudnik as a machine learning researcher on the team, and Itai Gabay, that's our he's leading our R&D team. And we have Neil Bensby that's been working with us on the computer vision as a consultant and is also here for any feedback. So anyway, I'm sure you'll have a lot to say. I know not everything's going to fit perfectly into the format of the call, of the community call. So anything that comes up, first of all, just write it within the Q&A, even if it doesn't fit perfectly. I'll be doing some of the moderating and seeing which questions we can do and when, and we'll try to answer some of them in text and some of them to raise and to discuss. And also, just remember, this isn't the only way to reach out. So anything you see here or thoughts, you can reach out within the Stack community is the best place to talk to us, either privately or just write publicly. And then, we can also set up either one-on-one types of beta testing sessions or focus groups. We're going to do all of that. So anyway, thank you so much for joining. I hope you enjoy both this and, of course, the usage of the package once it's more popular. So, Shira, your turn.
Sure. Yeah, I put the share screen on just a bit before, so everyone has time to enjoy the meme. So, okay, so let's get started. A bit about what we're going to talk about. So for those of you that aren't yet familiar, want a quick refresh of Deepchecks, generally the concepts, how it works, the targets. We'll start with a few minutes of that to give you kind of the framing and a bit of to see like what currently exists. Of course, you feel free to go later and explore also everything that already exists for tabular data. We're going to show a short demo of the Deepchecks vision package in its current development constellation, and talk a bit about the plans for the future. Again, one of the main purposes of doing like a community talk, is to hear feedback and to be able to adapt and change and prioritize our plans as well. So we try to build that in a kind of a way where we both present, but also incorporate your feedback. We will have a few during the talk. We'll have a few polls, so we'd really love to hear your thoughts or your votes for that, and also later on a short feedback form, which we'd love you to fill whatever you'd love us to hear. So let's get started. Deepchecks itself is a package that's aimed for enabling quick, efficient, comprehensive validation of machine learning models and data. So what does it mean to validate machine learning models and data? We see different aspects of the process. When we have a model, we have both the data, we have the process of like the methodology of splitting the data, training the model, retraining it, and all that part. And we have the model itself, its performance, evaluating it. We think that each of these things are things that should be checked, and many times they're also intertwined. So how is the package itself built? We have like the base component, which everything works with, is a check. A check gets some input, for example, the data, sometimes also the model, and it has an output. So can be usually like a graph, sometimes also like a numerical values. And the idea is that each check comes to check something. It can be things that are relevant for data integrity, things like leakage, things like performance. And well, you can see like the current existing checks in our documentation. And what we'll now, like in the rest of the session, we'll delve into the specific types of checks that we think are the most relevant or interesting for the computer vision and stuff, that like both the checks themselves and also the structure of how this is going to look and run in the vision context. But the check is the base component. When we run, what you can see here is like different outputs of different checks, and they usually have like a graphic output and also some additional info. And in order to be able to really validate also like many things together, we have something that's called a suite, which is essentially a list of checks that run together, and they can have optional conditions on them. So like enabling you to get a pass, no pass, and or like a warning to understand that maybe you want to delve into something deeper. I'll show quickly how this actually looks like in a notebook format in code. So in this case, we have the data, we import something that's called a full suite. The suite, in this case, it's like a pre-built suite with many checks implemented inside. And once we run the suite with the data and the model, we get here like the list of all the checks that ran. And we can see their status, and we can also go over the specific checks, get some more info, and see just like general checks that passed, and possibly also additional checks that like didn't have conditions. So the idea is really to have it like a framework that enables you to run it either separately, each check, or together. So that's a bit about the context, and let's dive into the vision module.
Great, Shir. Thank you for the great refresher. So now let's get to business and to the main content of this community call. So first, before I dive into the code and the checks that we started implementing, I wanted to discuss a few assumptions. And later on, a poll will be sent that in order to validate these assumptions. So first of all, the package currently will support PyTorch objects and only use cases of type object detections and classifications. Later on, we'll also support more use cases. Of course, everything here is up to changes based on feedback that we'll get here or later on in many channels that you can reach to us, because we're really oriented by the community.
We launched the poll simultaneously,
Yeah.
so we can like read it and input your info.
Thanks. So similar to the tabular package, we try to keep the same concept. So also here we have different types of checks for every step in the building model pipeline. For example, what I'm going to showcase today is that these 5 checks. The data set dimension, for example, is the part of the integrity checks to check that the data is correct. Label drift for checking if I splitted the data correctly, and performance and robustness to check actually check the performance of my model. So now I'm going to show you my notebook, my demo notebook. Great. So this notebook is basically building a model that aims to predict whether people wear a mask or not correctly. This is based on the Kaggle challenge that began in the beginning of the COVID pandemic, and it's also relevant today. So the first not so interesting.
I'll just say the poll is still up and running if anyone still wants to participate in the poll.
Yeah, Itai, if you want, maybe you can do like in a minute or two, you can like do a small pause, and we can also share if other people are also interested to see the results for a few seconds. But we'll leave it open for like a minute, and then and then if you want.
Great. So I'll run on the building model path, and then I'll stop to share the poll results. Great. Here I'm just building a model that aims to detect whether a person is wearing a mask correctly or not. So defining the data set, defining the transformation, splitting to train and test splits, and so on. Some usual steps most of you already know. Let's have a simple sample images from the training set. As you can see, we have, let's say, easy examples. For example, this guy, a single face in an image that is wearing a mask correctly, but we also have some more challenging examples like this image where we have multiple people, let's say a crowd, and we expect our model to detect whether everyone is in this image is wearing a mask or not. Of course, okay, each face is a bounding box, and this task is object detection. So for that, I'm building, I pre-built a faster RCN ResNet module. I'm not going to dive into details, but you can find the reference architecture and all the other stuff here. And for now, just checking my prediction, I can see that my model is okay, detects faces correctly and also mask correctly. Although in challenging scenarios, we can see it has some mistakes. Okay, so now before I dive into the how I validate my model with Deepchecks, I think it's a great timing to showcase the poll results. Great.
Yeah, so everyone can see them now. I say that it does generally match like what we thought or understood before. That's why also classification and object detection are the first two, and we feel that segmentation is the kind of a runner-up. Of course, we're asking this in different areas, so we're happy to see generally consistent answers. And yeah, you can see also the different frameworks. So we're happy to see PyTorch leading here. Of course, again, it's not a huge sample, but we're collecting them.
Yeah. My guess is that PyTorch is for the research phase and TensorFlow is a production phase, but interesting to see.
That was one of the options. That was one of the options, and people didn't vote for it that much. But
you know, we're
yeah.
A data-driven company, so we take polls and then we guess. But I'm just kidding.
you know, but you know what could have happened? I think that it could be that people that were kind of tipped off, maybe that were working with PyTorch just didn't join the call. So you know, sampling bias. But anyway, it is, you know, we would like to support everything later on.
Okay, cool. Interesting results, I must say. So now let's dive into the interesting part of what Deepchecks provide in order to validate your vision module. And I'm going to demonstrate the 5-check we showed in the presentation. So the first step here is actually the last step I want to discuss about. So I'll just leave it for later, but it's basically formatting the output in order to fit to an expected shape. After that, similar to the tabular package, I'm defining a vision data. This is an object that contains the data loader and also some metadata regarding the task type and some other things. This object can help us run our checks in a generic way. And now let's dive to the first check, the integrity check. We want to validate whether the dimensions of the images are, if we want to explore the distribution, basically. And here we defined a few metrics that we want to see. The first one is the distribution of the image width. And here we can see that we have various widths. I mean, we can say that this is not an easy task because we have different sizes of the images, both in the width and the height. That means that in the pre-processing step, we might lose some information when we try to rescale to a specific size. In addition, we can look at the number of bounding box distribution in order to understand that most of the images have between 0 and 5 bounding boxes, but we have this long tail. This may also affect the model, and I mean, these ones will probably be hard examples for the model. We need to take this into account. when we build it. Any question about this one?
So if you have any questions, then just type them in the Q&A and we'll make sure that they get answered.
We're monitoring both the chat if there's anything, but for question Q&A is a good platform.
I just wanted to say, Jeremy, I saw your comments about how TensorFlow isn't, that you're surprised. I'm also a bit surprised. I thought PyTorch would be more common, but I didn't know the gap would be this large. And I think it could be that the people writing both are kind of, more oriented towards one of them, but wrote both just kind of in case. That's one thing. But I think we could also take this to a wider survey. It's not just the participants. It's a lot of people here, but still, it's not that large a sample. So we can definitely do better with in terms of the sample size.
Yeah, we're limited in a Zoom webinar to 500 participants anyway.
Cool. So if there are no questions, I can move on to the next check. So the next one will be checking the distribution of the target variable. This helps me understand if I separated the data correctly, or maybe there is something that is going to prevent the model to perform well on the test set. So in object detection, again, we measure different measurements on the target variable and then calculating drift score between them. So the first one is the bounding box area distribution. As we can see, the distributions are much more similar between the train and tests. Also, I didn't say that the drift calculation and the algorithms we're using is taken from the tabular package, which basically I've gone some iterations, and we consider them a bit more stable. So we calculate them on these measurements. The second measurement will be the samples per class. We compare the classes distribution between the train and test set, and also the number of bounding boxes per image. Here we can see that we have a slight drift, but I think that's okay. Our model can handle that, but it's also interesting to know that. Any question about this one? Just okay. I see there are none. Feel free to write if you have any. Meanwhile, I'll move on to our next checks. So
also one thing, if someone prefers not to write an answer but to talk, you can raise hand, and then we can give you also permission to speak.
Cool. Okay, so now for the after I validate my my data set and validate I split the data correctly, and let's say I trained the model already. I want to validate it, to evaluate it in order to get different metrics and to understand how it performs. So for this check, this was quite challenging. Because there is no standard in terms of metrics, and there are many metrics that depends on the task types. Also in each task type, there are different evaluation metrics. So for now, the default metrics that we run on the object detection tasks are the mean average precision and mean average recall reports that are taken from the COCO dataset. And we're segmenting the mean average precision into different segments based on the bounding box area size, exactly like COCO actually doing it. So we show here the total mean average precision over different IOU thresholds, and also show it on a specific IOU threshold of 0.5 and 0.75. Here I can see that my model behaves it doesn't behave well enough on small bounding boxes, and I need to take it into account when I evaluate this model. Also, we can see here how the IOU threshold affects the mean average precision, and we can deep investigate the mean average recall report. And here again, we segment the metric into different bounding box sizes, and we also show we also taking into account a different number of predictions based on the model confidence. So here is the, when we take into account 100 predictions, here is just the top one, and here it's a top 10. So for each use case, I would like to look on a different column, I guess, but this provides an overview about how my model performs. Also, I must say that we also support the custom metrics. This may be more challenging to implement, but it's possible. Again, I would like to hear your opinions and your feedback about these metrics and what would you have done differently. We're open for feedback and we are willing to change accordingly. So this is one of the important checks we would like your feedback on. So if you have any questions, and just doing a stop break now in order to see.
Yeah, I'll come in for a second. So I have one question from Dmitry Frumkin that says, hello, it's a nice example, but very specific. I have another of custom attributes per image. How do I generate a report? So I'm not 100% sure exactly what the custom attributes mean, but if either of you, Itai or Neil, get enough of the question, then we can do that. And otherwise, maybe Dmitry, maybe I'll try to enable you to speak.
So I think he didn't understand well enough what Dmitry means in attributes. So Dmitry, maybe you can just elaborate a bit, and then we'll be able to answer.
It looks like Dmitry left the call right now. Okay. Yeah. Okay.
Okay. So I'll just do a guess and great.
Oh, he's here. Yeah.
Okay. So why did he disappear from where I am? I think yeah.
Here.
Now he has
Hello. Do you hear me?
Yes.
Yes. Hi. So I have a question. So here you looked at a very specific example where you're doing classification and you have bounding boxes, right? So now this is just one task, but suppose I'm doing something else. Maybe maybe it's a different task, segmentation, or there is some other pre-processing pipeline. And maybe I'm interested in some custom features of the image. For example, if I'm looking at maybe diversity of the subjects, I want to know, I don't know, how many people or animals there are, maybe the race, age, gender, or something else. So maybe I even compute those by myself, but how would I use your product to, how would it be helpful for me?
Cool. So I assume you talk about the drift checks or the dimensions checks.
Everything in general.
Great. Okay. So in general, we currently support in this upcoming release in two types of tasks: this classification and object detection. In the near future, we also plan to support image segmentation, and I would like to hear more about your use case and about what you're looking on when you build a image segmentation pipeline. In terms of different measurements and different things to look on, I think that each measurement you see here is configurable. Of course, we can't write each and every metric for each task type, but it's really easy to add a function that will return your measurement, and then we can calculate drift on it, for example.
Okay, so there's another. If it answers the question, Dimitri, then let's proceed, and if it doesn't, then maybe say what else you'd want to.
Yeah, I think I understood. Thank you very much.
Okay, great. So we have another question from Ofer Lavi. it seems that there's an artifact that map at K and R at K show here, or AR at K. The metrics are correlated with the size of the area. So I think either one of you or either one of the Niels or Itai should address this.
Just let me reread the question again. Yeah, I mean, maybe in this particular example, the metrics are correlated with the size of the area. In my specific, let's say, toy model here, but basically, it's not a must. I mean, the mean average. I mean, we are segmenting it to different area sizes in order for. I mean, this is, first of all, this is what Coco does, and second thing is, for different use cases, I'm gonna interested in different bounding box sizes. Let's say that for me now, it's more important to be better at small bounding boxes because that's my use case. So this segmentation can help me understand how my model behaves on these types of bounding boxes. I hope that answers your question.
And then I'll just add that this was something that we got some inputs about that it would be useful. It's not like by accident that we all notice the correlation, but the idea is you might be interested either in the differences or in just knowing how well you are, or you might have heard that you're heard from, let's say, someone that's a user that some segment of the bounding boxes isn't working well, and then you're trying to address that. Anyway, let me know if it's not answered.
Cool. So now for the cherry, let's say, I mean, I think that's the most interesting check we implemented in this release, the robustness model, a robustness check, and I see Nir Bentley is smiling here, so because he was a big part of it. So what we're trying to do here, I mean, in every cookbook, someone will write, yeah, you should check your model for robustness, but what does it actually mean? Actually, when we speak with the community, everybody is doing it differently, and we try to find a way that it will be generic for every type of model or data. So what we're checking here is how simple corruptions to the data set affect the performance of the data set. So I'll just show it first and then speak about it. So here I can see the mean average precision and how different corruptions I do on the data affect the performance. And I also see samples of these corruptions. For example, when I change the brightness and contrast, you can see sampled example of what's happening to the data set. And I can also see that it downgraded the performance in 13%. And I can explore much more corruptions that we're doing. For example, shift scale rotate, or use saturation value, or RGB shift. And actually, with this check supports any augmentation or imagog function of augmentation. And I mean, it just can be passed here. And our check knows how to handle it and to calculate the performance degradation. This may be really helpful when you try to evaluate your model, because sometimes I know that these types of corruptions does not apply to all use cases out there, but the fact that it's customized can help you guys to implement your own, or to use the specific corruption that applies to your use case, and then just see what happens to the data and also calculate how it affects the model. And when we speak about robustness and corruption, the last check I'm going to show you here is a suspicious robustness check. And in other words, it means what happened if I take the corruptions to the edge until even the human eye cannot distinguish, cannot understand what's in the image. For example, in terms the random brightness contrast augmentation. When I increase the level of the corruption, I can also see how the performance degrades. Or another example of the shift scale rotate corruption level, which is degrades a bit less, because we can see here that these specific corruptions, we can still detect people with masks. So it doesn't totally destroys the image. Again, also here you can see that the mask is always visible, so the corruption, the metric level is not doubling a lot. And the RGB shift, you can see that I see almost nothing here in the last steps. And as expected, the average precision is really low in this check. So on these two, we worked a lot, and your feedback is really important for us. So feel free to write about or ask questions. I'm willing to answer them, whether on these ones or on all of the checks. Let's take, 1 minute to answer them, then move on to the formatting part. So do we have any questions?
So I'll just say we kind of completed demonstrating in the notebook the current implementation of how a few of the checks look like. Neil will show a few more of our plans and like additional checks soon. So if there are either thoughts, suggestions, feedback about things that were presented till now, then this is a great timing. And if not, then I will warn that you should try to be very focused in the upcoming short session, because we will have a poll after it that's very, very related. I'll say that it's something that we really had a very challenging kind of thing to think how to tackle it. So we'd really love your feedback, and it's not necessarily something that you think about when you just like implement a specific task, because it has to do with like the being able to work with lots of different tasks in one framework. Anyway, I see there is a comment. So Philip, do you want to go?
Yeah, there's a comment. It's something between a question and kind of continuing a conversation we had in the chat just now by Jeremy Di Battista. So Jeremy's asking, he says, I think brightness is important as a corruption. And I'm wondering if anything is being done for an angle shift. So to see the same thing from a slightly different angle. I know these
okay.
are complex issues. I think, yeah, Nir, I think it could be angle like this, and it could be an angle like this. And even though
I think we did have we had the random shift rotate. I actually thought that we did have that, but yeah, this we do. That's the shift scale rotate.
Yeah. Wait, so I'll speak on behalf of Jeremy. I think one of the angle things we could look at is like this, but something else is something that's a bit harder to do, which is like imagine what it would look like from a completely different angle, like gun type thing.
Oh, like a projectile, projective transform, because that's also okay,
Jeremy, you and I go way back, so I know. Of course, I understand you.
Well, that can actually be easily added. I mean, I think the framework that we wrote perfectly allows to add your. I mean, first of all, if that's already implemented in one of the common image augmentation libraries, then you can add that within, I don't know, that it will take you literally a line of code to add that as well. And I think projective transforms are supported in both augmentations and image aug. And in the very rare case that they aren't, then you have to implement that on your own. But that's a pretty easy transformation to write. But yeah, specifically, I think this one is implemented within both common image augmentation libraries, so you can simply add that.
Interesting, but we should probably have that out of the box, right? Like, or pretty high up there.
I don't see a reason not to.
I mean, yeah. In order to support any known corruption, you can just pass it to the transform parameter, a list of your corruptions, whether it's from augmentation, the image aug, or something else, and it should work.
Yeah, the main thing to note is that, I mean, as far as I see this, the usability, the transformations should be still like within what would be considered a realistic image. And from my experience, a lot of times, projective transformations skew images in a way that makes them look unrealistic. But this is actually a parameter that you can set in listenable augmentations. We would look into that. I think that's a good idea to add that.
Great. So in our last 2 minutes of my presentation, I'm going to discuss the most challenging issue we had.
This is the part you have to stay focused for the poll. So.
Yeah, you must stay really focused right now. It's a live coding session. No, I'm joking, but it's really important. So as you probably know, there are no standard when it comes to the label formats or the prediction formats. And in order to create a generic package that will enable a slight run on and a clean run on our various check, we need a well-known format to work with, whether it's a format for the labels or for the bounding boxes or for the detections and predictions. Actually, the format currently Deepchecks support for the labels is this one, where X, Y, W, H are the upper left corner and its weight and height. And for the prediction format, it's the same objects, but with a confidence, which is the probability of the model. I must say that also we provide some utilities function to convert from other well-known formats, like for example the YOLO format, XYXY, and so more. But also and I know it happens a lot, if your model is not in this list of formats. So we expect a type of a function that will convert your labels and predictions to our well-known format, which is this for labels and this for the detections or predictions. And after that, in order to let Deepchecks know that these are the formats, we actually need to you need to create a formatter both for the detection and for the label, and then we just run it all the time and use the correct format in order to run the checks. So for this issue and also for the other checks that you saw, there is a poll. Here is the correct slide. We create a poll, and I would really appreciate if you answer it, because I think I mean this is one of the most challenging things we had when we try to think about this module. So I appreciate any idea, feedback, or something regarding whether it's one of the checks or the formats and conventions. So I mean, even let's take 1 or 2 minutes to answer the poll, and then Neil, the stage will be yours.
There's also a open answer at the end, which wasn't supposed to be a. You can just put a dot if you don't want to fill anything there, because I see it's required by mistake.
Okay, and in the meantime, Itai, I'm debating if we want to distract people a bit. We have a question from Itai. You know what? I think let's wait for let's give a minute of quiet, and only after we go into the question.
Sure, but Itai, maybe do show the previous, so like the notebook, so they can kind of see the example of a transformer and how it looks and the text.
Yeah, of course.
Maybe zoom in a bit also.
I hope that's okay.
And kind of constantly go down and up and down and up.
I mean, your feedback on these issues might change completely how we handle the formatting function. So it's really important for us to understand, what do you think? Even if the best thing you've ever seen in your life, just mention it in the poll. Don't be shy. In the meanwhile, I'll just answer the question from Itai. You have a nice name. Are the robust checks easily adjusted to voxels? So actually, not really. We didn't thought yet about 3D problems. I mean, I would love to hear more about the use case and how do you see that? And also, I would like you to, I'm inviting you to also contribute to us, whether it's a small contribution like creating issues or sending us, talking with us about your use case, or submit a pull request with everything you want to push to the package. By the way, it's a good timing to say we are open for contribution. We also had a few contributions in the past, and we really accept any contribution from you guys. I think we'll leave the poll open and continue.
Yeah, we'll leave it open like a minute more for those that still are reading, and then we'll close it. I think here there's probably less to share. It's more for our internal kind of collection. And thanks, Elad, also for the suggestion. Again, if you have any like standard formats, I mean, one of the things we did look about like how current data sets implement this, but feel free to write the suggestions here or in the poll.
Okay, so we move on to the next part.
Yeah. Do you want to talk about the poll for a second, or should we move on?
I think we can continue.
Okay. So first and foremost, I truly apologize for the bad puns. So I'm Nir, and this is plans for the near future. So what I want to discuss with you is a bit about what we're planning. Itai showed us what we already have in the demo notebook, and I want to discuss a few more additional checks that we're planning for the next version and the following versions, and also some what support for more frameworks and tasks we're planning. Of course, feel free to write any questions in the Q&A, and we'll also post a form for feedback. And don't worry, I will also sum everything up very nicely at the end, so we'll remember everything that we've gone through. Okay, so let's start with checks that we plan for the initial release that weren't shown in the notebook yet. We'll start with the problem of we have this train. It is part of a train test data set. And either I have the same image in both data sets, or I have similar images. For example, we're taking on different days by the same camera in a space of a few seconds with a bit different different properties. Doesn't matter. The images are either identical or similar, and they either and testing the model on them will not contribute to me very much, because the model already trained on a very similar image. This is of course the issue of leakage, and this is the first check that we want to implement to check for similar or identical images between the train and test data sets. Two additional checks that are very similar in method are doing the same, but for train versus train, meaning in the same data set, if I have similar or identical images, this is a redundancy, this wastes my resources, this doesn't interest me very much to train the model on very similar images, and this is also a check we will implement. The third one regards tagging. If the label, let's say this is a classification issue, and the first similar image is the Hogwarts train, because this is the Hogwarts train. If you don't know that, well, feel sorry for you. But another very fair label for this image will be bridge. Depends on the classification task at hand. These two very similar images with very distinct different labels could be problematic for the model. This is the issue of label ambiguity. And this is the third check in this series of checks we would like to implement. Another one is, say we have this train and we have the previous train and all additional trains, which are here the same bridge, the same train, etc. And there's and I have in my data set also another train from Russia. Doesn't matter. This is an outlier. It's not necessarily a bad thing, but I would like to know about this as a user, which outliers I have in each class, in each whether it's classification or in the bounding boxes. I would like to know my outliers and why they are different. Some additional checks, again, this is still for the initial version, we would like to implement is model inference time. This is just about the model prediction time, how much does it take it to run a forward propagation, just giving a report on that. The final check here is samples of low confidence. This is a display check. This is not a measurement, but more of a check that displays information. And again, here it displays images with low confidence. This means that whether I have, for example, I have a model that tells me if an image is a shore or not. So this is a shore, and the other image of a mountain is not shore. But for the desert, it's not sure. About the confidence. So this is a sample I would like to see as a user. These are the checks for the initial version. They are pretty simple to implement. And now we'll go over to the next version checks, to the following versions. Checks, there are 3 more. If there are any questions at this moment, we can stop and answer them, or we can continue. I see that at the moment we don't have, so let's continue. The next version, 3 a bit more complicated checks that we would like to implement. First of all is data drift. Data drift is the problem of the data changing between the train data set and test data set, or whether it was the test data set and the production data set. Doesn't matter, but the data changed over time. Common reason for that may be seasonality. Images that were taken during the summer will be very different from the images taken during the winter. This is the problem of data drift. How we would like to address this issue is, first of all, by trying to look for drift in very simple properties of the images. For example, the color histograms. Look at the distributions of color histograms on trained dataset images and compare that to histograms of test dataset images, and see if there was a significant drift between those two. Another property, this was actually an idea from a community member from Elad. I think I saw his name also here in the attendees. Is looking for drift in the bounding box centers locations, whether see this heat map, this map of locations, this distribution of locations of the bounding boxes in the train data set, and comparing it to the test data set and seeing if there is a data drift. In the future, this will take more development and research. We would also like to use the feature layer or embedding layer or abstractization layer, whatever you like to call it, of the users or third-party neural network, and use those features as the base of a domain classifier, which is a model that is trained to separate between the trained dataset and the test dataset, and thus can learn how and how much they are different. So this is data drift. This is the first check we would like to implement in the later future. The second one is simple feature contribution. Let's say I have a model that is trained to learn the artist of a painting. The Mona Lisa is, of course, by Da Vinci, and the sunflowers are by Van Gogh. But I would not want to know just that the model succeeded in the task. I would learn to know how. Because if the model identified this part and saw, oh, great, this is the style of Vincent van Gogh, this is great, this is what I want the model to identify. However, the model may have identified the color yellow. Van Gogh has a lot of yellow in his paintings, and the model may have just identified the color histogram of Van Gogh's paintings. This is the problem of simple feature contribution, meaning that a simple feature, simple property, not a complex property by a person, but a simple property can predict the label. And this is not what we wanted the model to learn to identify, because the test set might look a bit different.
Yeah, I just want to step in. Yeah, I just want to step in as a moderator for a second. No active questions, but we have 6 minutes left, and I want to leave some room for questions in case there are any. So.
We have just one last check, and then we're finishing up. Let's check quantized model performance. If I have a model that is 64-bit float, and for production for an edge device, I need to quantize it for 8-bit float. This is just a check that compares these two performances, because the second model, the quantized model, is much lighter and faster, but we want to compare their performances. That is for the checks we're planning. I will show a summarized list of them in a few seconds. First of all, I want to address additional features that we would like to show, to add to the next version. Support for TensorFlow. As said, we only support PyTorch at the moment, but we do want to support TensorFlow as well, and support additional tasks out of the box. Segmentation, regression, pose estimation. As I saw in the poll before, these were guesses for what is important, and it seems that we were right about this. We're going to go to summary and to go to the last part of Q&A. Before we do that, I just want to remind everyone, you can join the community Slack. You can become a contributor. Please join us. We'd love some extra hands on this. Summing up what we've seen today, in the demo, in the notebook that Ty showed us, there was the dimensions check and the other checks. I will cut for time, and I will just I think show you the complete list of what we discussed. And I think we can just open this up for questions, and then you can also see in the chat, you have a link to a form, to a feedback form. So even if you don't want to stay for the questions, please go into the forum and give us our feedback. We would really like to know your thoughts.
The feedback form is super short, so also if you want to just answer a few, but yeah, that would be what we go over this input seriously.
Yeah, I never believe people when they tell me the feedback form is short, right? You just, they have to get you to go in, and then once you're in, you're going to answer it. But yeah, it is pretty short. So if there are any if there are any questions now, you can either ask in the chat, in the Q&A or chat, or you can just raise your hand and we'll find you. And if there are no questions, then we'll like to divert your time towards the feedback form. And I just want to remind what I said at the beginning of the call. Right at the beginning of the call, you can reach out in other channels. We're having one-on-one sessions and focus groups, and this type of call is great to get kind of mass feedback all at once, and for you to see each other's comments. But we'd love to hear anything you have to say. So yeah, so there's
I see that question. Yeah, okay. So question. So Yal Gross asked, how does the simple feature contribution work? The general idea is taking properties like I showed in data drift, looking at the distribution of the color histograms and bounding box locations and maybe other meta properties of the image, and trying to see if a single trained model can predict the label based only on that feature. We do that in the tabular package as well. You can do it by using just simple covariance score, or there's a tool, the predictive power score package, very interesting article where they try to do the same. And we use that code as well. I hope that answers the question again. If not, you're welcome to tell us. But is there a list of such features? So again, the color, right now our thoughts are about the color histograms and the bounding box locations. We're open for more suggestions. We haven't brainstormed on all possible properties to use these features. And of course, later on, as said in the data drift section, we can also use the feature layer, the embedding layer, whatever, as the feature layer, as the features for these models that check for single feature contribution.
By the way, one of the things that we initially thought about doing is taking the metadata, like the EXIF data from the image, and then we understood that many data sets don't actually have it, so we really lowered the priority. But if you do have any such ideas, whether it's something like that or others that you think that you check or that you think can spot issues, then we'd really love to hear.
Okay, so you know what, we really want to be respectful of your time, and you know, we sent an invite for an hour, and we don't want people that can't stay more to miss out. But you know where to find us: Slack, GitHub, and any other media. So thank you so much for joining. I know that we had to have some inconveniences for everyone to be able to fit everyone from all these different time zones at the same time. And you were really great. Really, it's the first time, and I can't wait to do it for the next time. And let us know also if you think regular Zoom or this type of format, whatever's better, and we'll upload some sort of summary of it, hopefully. Bye.
And please go into the forum.
Good afternoon.
And
So good evening, good morning, good
forum.
afternoon, depending on where you are. And don't forget the feedback form, of course. Thank you so much. Bye.